All right, page 3. We are almost done here. I'm going to blow through this page because much of this is a repetition of what we've been doing, what we've been doing in class, and so far through this demo here. Wallace and Gromit are on another project for their pest control business, Anti-Pesto. This data shows the number of snails they have each hour, probably the number of snails they capture each hour. So here are 4 ordered pairs, 038, 1, 158, 2, 278, 3, 398. Okay, 0 at time equals 0. So let's take a look at what these variables are. It looks like we have number of snails they have each hour. So it looks like number of snails is our dependent variable, and it's dependent on each hour. Okay, so at time 0 they had 38 snails. After 1 hour they had 158. 2 hours went by, they had 278. And 3 hours went by, they had 398. Okay, so the thought process is tell me how you got from 0 to 38, 1 to 158, 2 to 278, and so forth. Well, using kind of our standard process here of, remember, our y equals some rate times our x, our multiple. Remember, this is our rate of change plus our constant. And remember, our constant is whatever we start out with. So at time 0, they had 38. So it looks like we're adding 38. And what are we increasing by each time? It looks like from 38 to 158, that is a positive increase of 120. And that's when it just increases each hour. So it looks like the rate of increase is 120 snails per hour. So the thought process in this case was 120 times 0, and that's pulled from that 0 right there, plus 38, and that's how we get 38 over here. So the rest of our thought process here would be 1x plus 38, or I'm sorry, let's see here. The rate of change we said was 120 times 1 plus 38. This is 120 times 2, 120 times 3, and so forth. The independent variable, very important because our independent variable is always our x variable. And so in this case, it's a time variable, so it's hours. What depends on hours? Well, number of snails they catch. The domain, remember the domain is the set of all x values. So in this case, it's 0, 1, 2, 3. The range in this instance is all set of y values. So 38, 158, 278, and 398. Write the pattern rule for this data. Well, we already have our pattern rule up here. It's 120 times the number of hours plus 38. So f of x, and remember what's x stand for? It's our hours, so our function in terms of hours is equal to 120 times the number of hours plus 38. And suppose we want to find out how fast Wallace and Gromit are collecting snails each hour. What is their rate? Include the units. That is the key element here, because our rate is meaningless if we don't include what units we're talking about here. And we can always find our rate by looking at a few different things. we can always take a look at this number here that sits in front of the x. That is always our rate. And where do we get this value from? We get it from our table up here, because the difference between 38 and 158 is 120. 120 what though? 120 snails per every 1 hour. 120 snails per hour. And we can see that because when 1 hour goes by, every time 1 hour goes by, 1 hour, they catch 120 snails. So that's 120 snails every 1 hour. 120 snails per hour. Use the given function to answer questions 19 through 21, 3 points each. It looks like we have f of x equals negative 8x minus 18. What's a situation that could be represented by this function? The key thing to remember here is that we're starting out with a negative 18 something. So what I might write would be I started measuring the time in hours. Time in hours at time equals 0 hours. It was negative 18 degrees outside. As each hour went by, the temperature dropped 8 degrees. And so let's see if that squares up with what the situation is. At time 0 hours, so if I set this x equal to 0, doesn't that cancel out this whole term? So at time 0 hours, it was negative 18 degrees outside, so that's our constant. That's what we start with. And then as each hour went by, the temperature dropped 8 degrees, a negative rate because the temperature is dropping. So that dropping in temperature is how I accounted for in my example for this negative sign right here. And 20 and 21 are pretty straightforward. If x equals 8, what's the value of the function? All you do is just take negative 8x minus 18, and you would substitute 8 in for x. So negative 8 times 8 minus 18, so forth. Find the value of x when f of x equals negative 50. So remember our function, I'll rewrite it again, f of x our rule is negative 8x minus 18. So if f of x equals negative 50, so in my example, if the temperature outside was negative 50 degrees, how many hours went by? Negative 8x minus 18, and now it's a multi-step equation. We add 18 to each side. We add 18 to that side, so that means we need to add 18 to this side. And so that leaves us with 32. Negative 32 equals negative 8x. Divide by negative 8 on each side. That leaves us with x equals 4. So 4 hours went by and it was a negative 50 degrees outside is basically what we just found out.